So good day everyone, I am Prince Andre B. Monroy from BSCS 3S2 and I am here to discuss what is hierarchical clustering. So first, let us define what is hierarchical clustering. It is a method of grouping data points based on their similarity where points in the same cluster are more alike than those in different clusters. Unlike k-means, it does not require specifying the number of clusters beforehand. The results are visualizing using dendrogram, a tree-like diagram showing how clusters are merged or split. The two main approaches are agglomerative, which is bottom-up, where each point starts as its own cluster and similar clusters are merged iteratively, and the divisive top-down, where all points start in one cluster and are split iteratively. Applications include customer segmentation, document organization, gene protein analysis, and social network community detection. So why use hierarchical clustering over k-means? It's no need to predefine the number of clusters and captures hierarchical relationships between clusters, which k-means does not. The application is used for understanding natural groupings in data. It allows flexibility and deciding the number of clusters by analyzing the dendrogram and cutting it on an appropriate level. So key libraries for hierarchical clustering include pandas for handling datasets, cephalic cluster hierarchy for hierarchical clustering and dendrogram creation, and sklearn cluster agglomerative clustering for implementing agglomerative clustering. Visualization tools like Seaborn and Matlab PyPlot are used for plotting, while scalar metric silhouette score evaluates clustering quality. The standard scalar ensures numerical features are standardized for fair clustering. The process involves selecting relevant numerical features, which is the income and the spending score, normalizing them for forming hierarchical clustering with methods like linkage and F-cluster, and evaluating results using silhouette scores. Visualization includes dendrograms and scatter plots to interpret cluster structures and outcomes. To prepare clustering, relevant features are selected. To define hierarchical clustering or relationship with words method commonly used to minimize variance within clusters and ensure compact, well separated. The linkage matrix establishes these relationships and supports dendrogram plotting. Dendrogram visualization simplifies cluster analysis by truncating to the last 12 clusters, rotating and resizing labels for clarity, and showing cluster hierarchies and dissimilarities as vertical lines. Clustering quality is evaluated using the silhouette score, which ranges from -1 to 1. Scores close to 1 indicate well-separated clusters, while values near 0 suggest overlap and negative scores imply poor form clusters, and the inputs include selected features and cluster labels. The dendrogram helps identify three distinct customer clusters: an orange cluster with tightly packed and similar data point merging at lower distances from greater to 250, a green cluster forming a middle ground group merging at a slightly higher distance from 150 to 250, and a red cluster, a distinct or outlier-like group merging with others only at the highest distance, which is 400. By drawing a horizontal line at 250, three clusters are emerged as optimal choice, with some compact clusters merge at lower distances while more distinct groups merge at higher distances, and the silhouette score of 0.367 indicates moderate clustering quality, suggesting that while some points fit well within their cluster, there may be overlap or loosely defined group boundaries. These insights can be guide businesses in segmenting customers for targeted strategies based on annual income and spending score. To form clusters, a threshold height of 150 is defined, cutting the dendrogram based on the Euclidean distance to separate the data. The linkage matrix computed earlier using Ward's method contains hierarchical relationship between data points. When visualizing the dendrogram, parameters like the truncate modulus and p is equal to 10 simplify the view, while color threshold 0.7 to the max adds color for clarity, with a red dashed line indicating the threshold. Divisive clustering starts with all data in one cluster and splits it into smaller groups. At 150, three distinct clusters are identified. Cluster quality is evaluated using the silhouette score, with values close to 1 indicated well separated clusters and values near to 0 or negative suggesting overlap or poor clustering. The dendrogram visualizes cluster and their dissimilarities along the y-axis, where clustering merge to below distance of 150 are more similar and those merging above it are less similar. The red dashed line at 150 divides the data into three distinct clusters. An orange cluster with closely related two subclusters, a green cluster representing a mid-sized group, and a red cluster as a unique group, merging only at the highest distance. The silhouette score of 0.434 indicates moderate clustering quality, suggesting that the clusters are somewhat well-defined but may have room for improvement in separation. In this approach, the number of clusters is predefined as 5 based on the dendrogram or business requirements. The agglomerative clustering model is used for starting with each data point as its own cluster and iteratively merging them on base similarity. Worst method using minimizing the variance within the cluster, ensuring the cohesive model. Annual income and spending scores feature and predict the cluster for each data. These labels are often added to the dataset as the new cluster. The scatter plot visualizes the customer cluster based on annual income and spending score, with each point representing a customer colored according to its cluster label. The central shown as a black or X markers represent the average values of annual income and spending score for each cluster, providing insight into a central tendency of the groups. The plot includes a title axis, labels, and a legend to clarify the data being visualized and explain the meaning of the cluster colors and centroid markers. In hierarchical clustering, individuals are grouped into 5 clusters visualized in distinct colors: the blue, orange, green, and red, and purple. Based on their annual income and spending score, unlike K-means, the number of clusters is not predefined. Instead, the algorithm starts with each individual as its own cluster and iteratively merges the closest cluster. It represents the geometric centers of each group for visualization, not the calculated centroids. For the cluster analysis reveals that cluster 0 or blue contains wealthy individuals who are conservative spenders. Cluster 1, which is orange, represents middle income balanced spenders. Cluster 2, which is green, includes high income, high spending premium customers. Cluster 3, which is red, group low income, high spending individuals. And cluster 4, which is purple, consists of low income, low spending scores, and likely or lower priority of businesses. So in this analysis, the hierarchical clustering is applied to the dataset for the different values of K from 2 to 10 with the feature scale using standard scaler to ensure equal contribution to each features. So a plot is generated with silhouette scores on the y-axis and the number of clusters on the x-axis. The peak of the graph indicates the optimal numbers of clusters as it reflects the best separation between the groups. So the silhouette score analysis suggests that the optimal number of clusters is K is equal to 5, with a score of approximately 0.55, indicating the best separation and cohesion among clusters. For the K values between 2 and 4, the silhouette score improves, showing that the more clusters lead to better separation. However, for the K values between 6 and 10, the score decreases, indicating that further splitting may cause over-segmentation and reduce cluster. At K is equal to 5, the clusters are cohesive and well separated, with points close to their centers and distinct from other clusters. This configuration aligns with earlier clustering results and supports its issue for further analysis, such as customer profiling or targeted marketing. Thank you for watching, and I hope you learned something.